Hello students, in this video let us see the random scan displays and the raster scan displays in a CRT monitor. A raster scan is nothing but a rectangular array of points or dots. So that is nothing but these grids. Okay, we can say it as rows and columns. What intersect the point, we call it as a pixel. Okay, and the line or the rows what we call it as a scan lines. Okay, usually it's called the horizontal strips and we call it as a scan lines, uh, which are like further divided into pixels for processing a computer system. So this is actually how our screen looks like. Okay, when it is in a very uh, in a zoomed manner, if we see, then we can see the screen is displayed like this. See, a small point on an image looks like this. If you maximize it or if you zoom it, you can see it like this. So this, what about the lines and rows and columns you can see, we call that as each a pixel. Okay, so how does this raster scan system work, or how does the displaying of this technique is works? Okay, in the raster scan system, the electron beam is swept across the screen, one row at a time from top to bottom. As the electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. That is, whatever the image should be coming in that line, that is in the scan line, according to that, on and off of the intensity is done. Okay, that happens, and because of this you can see the image. The return to the left of the screen after refreshing each scan line is called as a horizontal retrace. That is, what moves horizontally, we call that as a horizontal retrace. At the end of each frame, the electron beam returns to the top left corner. That is, once the whole screen has been scanned or the horizontal retrace happens, then it has again should go to the left top. Then we call that as a vertical retrace. See, this is the raster scan display, how is happening. So electron gun connectors are there. There is a control electrode, focusing electrode, and horizontal deflection plates and vertical deflection plates. This is the electron beam that comes from this electron gun. Okay, so because of this horizontal and vertical deflection plates, the electron moves according to how the electron beam should hit the phosphor coated screen. Okay, this is the phosphor coated screen, and according to these deflection plates the electron will be moving. Okay, so what happens at the start when the first this screen is illuminated, or if you want to see the picture, or the power supply is on to your CRT system, it starts from here. This is the start point, we call it as a start sweep. Okay, from here these are the scan lines, that is the horizontal retrace happen. That is, this is the scan lines, in the sense this is where the images are being drawn. Okay, these electron lines, whatever beam, whatever it's there, it first falls here. Whatever the image it has to be displayed falls here. Okay, it comes here. So when it reaches the right end, okay, what happens, the beam should go to the next line, right? For this we call it as a horizontal retrace. Okay, because it again comes to the starting to the left. Okay, then again whatever the image has to be drawn, it comes here, it draws, and again it should go to the starting of a left. Okay, of the left side. So this happens, and whatever the beam just passes from right to left, okay, in between, we call that as a horizontal retrace. So this happens until when? Until it reaches the end of the screen. Once it reaches the right bottom, what happens? The beam should go again to the top, that is the left top. So what happens when it moves from this to this point? We call that as a vertical retrace. Okay, so this is when a raster scan display works. So picture definition is stored in the memory area called as a refresh buffer or the frame buffer. So whatever the information is required to draw an image on the screen, that is stored in the refresh buffer or the frame buffer. So it is a memory area that holds a set of intensity values, that is what part of the screen should be illuminated to what extent, okay, is stored here. Okay, then stored intensity values then retrieved from the refresh button and painted on the screen, that we call it as a scan line. Okay, one row at a time it happens and we call that as a scan line. See, like this, it starts from here. This is where this is scan line, and where the image has to be followed, it is happening. Now see, the image what we want is a triangle, so it just flows through this. Okay, the electron beam flows through this, but the image is not formed. So image where it is formed, here it comes here, the horizontal retrace, again it starts, and here the information is there that this area has to be illuminated. So this gets illuminated. Okay, and this passes here, again the horizontal retrace happens, it comes here, and when it comes to this line, see, this area and this area, okay, should be illuminated. So those two areas get illuminated, comes to the end, again the horizontal retrace take place. Then it comes to this area, and here the illumination takes place. Okay, so when this whole thing happens, okay, see up to here, when it happens, at the end, when it comes to this end, you will have an image where the illuminated areas have been marked like this, and you get this as a triangle. Okay, so this is how the display actually happens in a raster scan. So the quality of images depends on the resolution or the pixels, that is how near your rows and columns are being intersecting. Okay, and we can also call it as a color depth. Okay, black and white system, each screen point is either on or off, that is only 2 points we have, that is either it's on or off, black and white, right? So only 1 bit per pixel is needed, and for this we call it as a bitmap. Okay, we call that as a bitmap image. And high quality raster graphic systems are 24 pixel. Okay, in one frame it can store a full color system or a true color system, we call it as a, so it has 24 bits per pixel. And refreshing on raster scan displays is carried out at the rate of 60 to 80 frame per second. Okay, so per second 60 to 80 frames are refreshed. So there is one more term called interlacing, that is, see, whatever I have explained till now, that is, one scan line, it goes, it comes to the next line and all that. So what happens, it takes time, right? To start from one like left top to right bottom, it takes some time. So what they do, they skip one line every time, okay, and display the image. So on some raster systems, the frame displays in 2 passes using an interlaced refresh procedure. So instead of just one pass, there will be 2 passes for one image to to see, so that you can see the image on the screen. There are 2 passes. So it is used for a slower refresh rate. If the refresh rate is slower, then this is used. An effective technique to avoid a flicker in the sense that actually just comes and goes every time. Okay, we call that as a flicker. So it occurs in the CRT when they are driven at a low refresh rate. Okay, so to avoid this, so that you can have a better image, see, our eyes cannot distinguish the slower motion of this thing, the image, that whatever the display is happening. Since this happens at a quite speed, okay, our eyes won't notice it. But if the refresh rate goes slow, then our eyes can see, and we can see the images being drawn like bit by bit. So to avoid that, we are using this technique. So this is it. See, at one time only this red color goes, that is, we may call it as an even field. Okay, So this comes, this is displayed, again horizontal retrace, this is displayed, horizontal retrace, this red color is displayed, and all that happens, it comes to the end, it goes back. Okay, then the odd field comes into picture, that is after this vertical retrace it comes to the next line of the original one, so that in between these two lines one more line is being displayed. Okay, so what happens once you do this, like once the image will be produced, okay, then to get a better image or the better view of the image, what we do, in between these lines we have one more line, same thing happens. See, this is displayed, again the horizontal retrace, again this comes the horizontal retrace, then this will be displayed, horizontal retrace happens, everything comes here, and again it goes back to this even field. Okay, so that whatever the image you see, it is very brighter and you get to see the clear picture. Next is the random scan display. That is, a random scan display is used for the geometrical primitives such as points, lines, curves, polygons, which are all based upon the mathematical calculations. Okay, in that case we use this random scan display. So this is how, you know, an image, vector image, whatever it is, you try to draw it. So every part of it is taken as an known mathematical object or a image, and then is try to draw. So, when operated as a random scan display unit, CRT has an electron beam directed only to the parts of the screen where a picture is to be drawn. Unlike the raster scan. In raster scan, what happens? Every point from start, like left top to right and everything will be scanned once, and wherever the image is to be displayed, that part will be illuminated. But here, where the diagram has to be drawn, only there the electron beam just passes through the screen. Okay, so they draw picture one line at a time, and for this reason they are also referred to as a stroke writing or calligraphic displays. See, this is how it is displayed. See, this is the electron beam, it starts from here. See, you want to draw a triangle, in the last we have seen it comes from the this lines, scan lines, right? Here what happens, you want to draw a triangle, it comes to the base of the triangle, draws like this, goes up like this, and finishes it. Okay, where you have to draw, only there the electron beam flows. Okay, this is how it happens in the raster scan display. So here refresh rate depends on the number of lines to be displayed. If the picture is very just of 3 lines and all, it's very easy to display it on the screen. Otherwise, so many refresh rate has to be refreshes has to be happened so that the picture can be seen. And picture definition is now stored as a line drawing commands, an area of memory referred to as a refresh display file or display list, where there we used to have a frame buffers. Here we are storing it in refresh display file. So to display a picture, the system cycle through the set of commands in the display file, drawing each component line in turn. Okay, so there, whatever, even if there was a picture or no, you had to scan the lines, but here only where the line has to be drawn, only there the line will be drawn. Okay, through the set of commands, and they are designed to draw all the component lines of picture 30 to 60 times each second. Okay, so this is how raster scan system produces jagged lines and are plotted as a discrete points. See, this is how the outline will be there and filled will be there. Okay, so this is how a vector display will be there. The vector display will be the very smoother one. Okay, this one see in a very what to say in the screen, normally when you see it looks like this, but if you zoom, it is actually made or drawn this way. Okay, so this is a raster scan, how it produces a diagram, and this is the vector display that the diagram is drawn. Thank you.